Okay, pre-cal students, in this video, we will begin our study of Chapter 1. Now, Chapter 1 is all about functions and their graphs. Today, we will start with an intro to functions, okay? Most of the information, if not all of the information, should be a review for you from Algebra 1, Algebra 2, okay? Alright, here's your heading for today. If I can get this pen to work. Here's your heading for today. Functions, lesson 1.1, and be sure and include today's date, okay? Functions, lesson 1.1, and be sure and include today's date, alright? Okay, here we go. Now, let's start off with a definition of functions. Please copy this in your notes. Function, it is a relationship or equation in which each input has exactly one output. Please copy that down. A function is a relationship or equation in which each input has exactly one output. And when I say relationship, sometimes it can be ordered pairs, sometimes it can be a graph, sometimes it can be words, and sometimes it can be an equation, okay? So a function is a relationship or equation in which each input has exactly one output. Now, as we get into our study of functions, let me go back first. Let me give you an example of what I'm talking about here, okay? Please watch carefully. If I had a list of numbers, when I say input, first of all, students, I'm talking about something like this. You can take notes on this or you can watch. I have an input for my x. Let's say I put in 3. And when I put a 3 in, I get an output for my y value. My y is my output of 1. So I put in 3 and I got out 1. So 3 is my x value. We also call that my input. So 3 was my input and 1 was my output, okay? So that's what I mean when I say input output, okay? Now if I gave you a list of numbers like this, if I say here's your input numbers, say 1, 2, 3, 4, and over here's your output numbers, 7, 8, 10, and 15. Would this represent a function? Well, let me ask you a question. Did each input have only one output? Yes. 1 had a 7, that's one output. 2 had an 8, that's one output. 3 had an 8, that's one output. And 4 had a 10, that's one output. What about this number here? I don't care about that number. Each input had one output. Now, if there was a 5 in the circle like this, and the 5 didn't have any arrow coming off of it, then no, this would not represent a function because this input here had how many outputs? None. It had no outputs, none, okay? But when it's like this is totally a function. Now, if this 1 had another arrow coming off of it going to the 8, then I would no longer have a function because the number 1 gave me 2 outputs. It gave me an output of 7. And it gave me an output of 8. And so then you would say, no, this illustration here does not represent a function. Okay, so that's what I mean when I say input, output. Now, as we get into our study of functions, there are some words that we are going to use interchangeably. Please be very familiar with these words. Write these down, please. We're going to use all of these words here interchangeably. Domain, independent variable, usually x. Input, the non-isolated variable. So, if I had an equation like this, my domain would refer to x. My independent variable would be x. Usually, the domain and the independent variable and the input and the non-isolated variable, usually they're x. And in this case it is. X would be your input. X would also be the non-isolated variable. Please make note of all of these. We're going to use these 1, 2, 3, 4, 5 words or 5 phrases interchangeably. Domain, independent variable, x, input, the non-isolated variable. Okay, these words here, copy these down. We're going to use these words interchangeably. Range, dependent variable. Usually the y. Output, isolated variable. Just how they're different. Independent, this one's dependent. Input, this is output. Non-isolated, isolated. Usually x, usually y. Okay, domain, range. So here's the equation I had just a second ago. Your range is referring to your y. Your dependent variable is referring to your y. And why do we call this the dependent variable? Because, students, it's dependent upon what you put in for x. Y stays what it is until you put a number in for x. And once you put a number in for x, then you get out a y, and that's what we call y a dependent variable. It's dependent upon x. Okay, all right. Usually your range is going to be your y. We also call it your output, and we also call it the isolated variable. It's usually the variable all by itself right here. Okay, so we're going to use these phrases interchangeably. All right, moving on. Now, let me give you some examples of these in equation form so you can see what we're talking about. Okay, all right, copy this down, and I'm going to write it in function form. Remember, this is called f of x. F of x equals x squared minus 6. Okay, now you know by now f of x is the same thing as just saying y. I have no problem with that. And so you would see x would be your range, your dependent variable, your independent variable, your input, and it's the non-isolated variable. Your y would be your range, your dependent variable, your output, the isolated variable, okay? Or f of x, same thing. F of x would be your range, dependent variable, output, the isolated variable, okay? So these are examples in equation form. Let's look now at some scenarios and decide whether or not they represent a function, okay? So here we go. Is this table of values a function, or does this table of values represent a function? Students, go ahead and copy this down. Now remember, this is the exact same thing as having an input circle of 2, 3, 4, 5, and 2, although 2's already up here. And your output over here is going to be 11, 10, 8, 5, 1. 2 goes to the 11, but notice the 2 also goes to the 1. So right away we know we don't have a function, because the input of 2 gave you an output of 11 and 1. Another way to look at it is like this. I have ordered pairs, 2 and 11, 3 and 10, 4 and 8, 5 and 5, and 2 and 1. 2 gave me out an 11, and 2 also gave me out a 1. Thus, the input of 2 had 2 outputs. This does not represent a function. It does not. Okay, let that sink in. Hope that makes sense, alright? Each input must have exactly 1 output. Alright, let's decide if a given equation is a function. We're going to look at 3 of these, okay? So let's look now at given equations and see if they're a function. Okay, now, I would like you to write these questions in your notes. It's very important that you listen to the reading of this question. Do the following equations represent, listen to this, y as a function of x? Do you know what that means? You need to know what that means. Students, you need to know what that means. It means this. It means y equals, and then everything over here has to be in terms of what? X. There cannot be another variable over here. Okay? Y as a function of x. Now, students, if I said y as a function of x and z, then you could have x over here, and you could also have some z's over here. That'd be fine. Okay? So whenever you see this phrase here, y as a function of x, it's saying y is dependent upon x, or y is written as a function of x. So if this was turned around, if it said, is x a function of y, then you would want x by itself, and the only variable you would want over here would be y. Now you can have numbers and stuff like that, but the only variable that you can have over here is y, because y as a function of x means y dependent upon x, or y written in x written in terms of y, or x dependent upon y. Okay? So, when it says, do the following equations represent y as a function of x? Let's see if that's true. Let's take our first equation here. Since we're trying to take this equation here and see if it represents y as a function of x, that means I want to get what all by itself? Y. Y is a function of x, so y equals 1 minus x squared. Now, put some numbers in for x and see if you get out one value for y or two. You're like, well, duh, Mr. Earhart, I'm going to get out one value. Well, let's still make sure. Put a 0 in for x, and you get out 1. Put a 1 in for x, and you get out 0. Put a negative 1 in for x, and you still get out 0, because negative 1 squared is 1. Put a 2 in for x, and what do you get out? Negative 3. Put a negative 2 in for x, and what do you get out? Negative 3. You do, Mr. Earhart, yeah. Put a negative 2 in there. When you square negative 2, you get positive 4. So you have 1 minus 4, negative 3. But you know what, students? I'm totally okay with all of this. Each input has only one output. Every time I put a number in, I got how many numbers out? 1. So this is totally y is a function of x, definitely. So this one's good. This equation here is definitely represents y as a function of x. Let's take a look at the next one, okay? Alright, let's get y by itself. Here we go. First of all, y squared equals 1 plus x. Bring the negative x over and make it a positive x. Next, I want to get y by itself, so we're going to take the square root of both sides. The square root of y squared is y. And the square root of 1 plus x, don't forget, you inserted it in, so you must put plus minus. Now, is y all by itself? Yes, it is. So let's put a value in for x. Let's see what we get. Let's put 0 in for x. And what do we get out? Well, 1 plus 0 is 1. The square root of 1 is 1, but there's a plus minus right here. So I get out a 1, and I also get out a negative 1. Let's go over that again, okay? If I put a 0 in for x, 1 plus 0 is 0, so I have the square root plus minus the square root of 1, which gives me positive negative 1. So look what I did. I put one number in, and what number did I put in? 0, and I got out two different numbers. That means my input of 0 had two outputs. So this equation here does not represent y as a function of x. Hopefully you're getting the hang of this, okay? Alright, let's try this one here. Let's try y minus 2 equals 0. Let's go ahead and get y by itself. Y equals 2. Now this one here can be a little tricky, because really there's no x for you to put a number into. So in a case like this, I strongly recommend that you graph it and get a picture of it, okay? So let's graph y equals 2. That's going to be a horizontal line passing through the y-axis at 2. Now think of all the ordered pairs. This ordered pair would be 1, 2. This ordered pair here would be 3, 2. This ordered pair over here would be 6, 2. This ordered pair here would be negative 1, 2. Do you see what I'm saying, guys? Every input will definitely have only one output. If I put negative 5 in, I'm going to get out what? 2. Negative 5, 2. Any horizontal line will always be a function. Let me say that again. Any horizontal line will always represent y as a function of x. Always. Don't forget that. By the way, any vertical line will never represent y as a function of x. Never. Okay? So let's review very quickly. When I ask you, does an equation represent y as a function of x, get y by itself, put some numbers in for x, and see if you get two values out. Okay? Alright, moving on. Let's finish up by evaluating functions at a given value or expression. Let me show you what I mean. Okay, here's your function. G of x equals negative x squared plus 4x plus 1. We're going to evaluate this function at the given values or expressions below. Let's start off with this here. This g parentheses of 2 is read g of 2. That means you're going to put 2 in for x. So g of 2 equals negative, then put parentheses for x, then plus 4, then parentheses for x, and then plus 1. You square your 2 first. That's 4. Then bring your negative sign down. Negative 4. 4 times 2 is 8. Plus 1. That gives you 5. So g of 2 equals 5. Now a lot of students get this far, and it's kind of funny. They then divide both sides by 2. Whoa. Hold on a second. This g of 2 just simply means you put 2 in, and you got out 5. In other words, it means this. Okay, you're done when you get here. G of 2 equals 5. In other words, you put in 2 and you got out 5. So there we go. We evaluated the function at what number? 2. Alright, let's try the next one. Let's take a look at G of t. G of t. Alright, now everywhere there's an x, I'm going to put t. Negative parentheses t squared plus 4 parentheses t plus 1. Alright, be careful, here we go. Square the t first. T times t is t squared. Then put a negative with it, negative t squared. 4 times t is 4t. Then bring down your positive 1. And students, guess what? You're finished. You can't simplify anything. There's no like terms. So there you go. G of t equals this. Another way to write it would be t, comma, negative t squared plus 4t plus 1. Okay? Input, output, input, output, input, output. Okay? Alright, let's take a look at this other one. Then we'll move on. You can work at it if you want to. Or watch me. It'll be a little more difficult now. Okay, here we go. I have g of x plus 2 equals, everywhere there's an x, I'm going to put g plus 2, so negative sign, then parentheses for x, x plus 2, then positive 4, x plus 2, then plus 1. Now remember, when you square x plus 2, that does not mean x squared plus 4. It means x plus 2 times x plus 2. Okay? So, I'm going to bring down my negative sign, put a big parentheses, and I'm going to get x squared plus 4x plus 4. Okay? Now, next, take your 4 and multiply it through. 4 times x is 4x. 4 times 2 is positive 8. Bring down your positive 1. Now, see this negative sign right here? It goes to everything inside the parentheses. So, negative x squared, then negative 4x. But I've also got a positive 4x, so they're going to cancel out. So I'm just going to leave that alone. And then negative 4 plus 8 plus 1 is going to be 5. Okay, so g of x plus 2 equals this right here. Okay, once again, negative x squared, then negative 4x would cancel with your 4x. Negative times a positive 4 is negative 4, plus 8 plus 1 is a positive 5. So g of x plus 2 equals negative x squared plus 5, or you could write it like this, like an ordered pair. X plus 2, comma, negative x squared plus 5. Input, output. let's evaluate a piecewise function. Go ahead and copy this in your notes and make note of this in your notes. We call this a piecewise function, and it's very obvious why, because it has pieces. It has a piece right here and a piece right here. Now students, please listen to me carefully. Notice, oh, this should be x squared right here. Please fix that. This should be x squared right there. I forgot to make that an exponent. Now students, please listen to me. F of x equals this right here, and it equals this. Look students, you cannot put just anything into this x right here. It has to be numbers less than 0. That's what this means right here. X is less than 0. So you cannot put 0 in for x. You cannot put 0 in for x. You cannot put 1 in for x. You cannot put 2 in for x. The only numbers you can put into this piece right here is numbers that are less than 0. Okay? Now, this part of the function here, the only thing you can put in for this x right here are numbers greater than or equal to 0. So you could put in 0. You could put in 1. You could not put in negative 1. You could not put in negative 2. So when I ask you to evaluate this function at what? F of negative 1, you've got to ask yourself, which one of these two pieces am I allowed to put negative 1 in for? Well, it's not this one, is it? For this function right here, this piece right here, all of your x values have to be greater than 0. For this function here, all of your x values have to be less than 0. So negative 1 is less than 0. So you do not put negative 1 in here. You put negative 1 up here. So it would be x squared plus 1. Negative 1. Negative 1 squared is positive 1. 1 plus 1 is 2. So f of negative 1 equals 2, or input of negative 1, output of 2. Pretty simple little function review. I hope this video has been a help to you. If you have any questions, don't hesitate to call or email.